It is the, yeah, it is the 28th. Why do we keep doing this? All right, so we're going to look at average value for a continuous function. So it is the mean value theorem for integrals. So let's talk about how we find it before we worry about what it really is here. So if I have, let's say that I have this function that looks something like this, okay? I have the going from A to B, right? Okay, so I've got some value in there, and I know how to find the area, right? What does the area under that curve tell me? Is it like how fast something happens or how much something is? How much, okay? Remember, derivative is how fast, or this, how fast or slow. And then the integral, which would be your area under the curve, that would be how much in general. Make sense? Okay, so let's say that I'm going from A to B. I have all of these different y values in here, but I want to know what is the average of all of those infinite amount of y values. Okay, so let's redraw this over here, something similar. It doesn't have to be exact. Something like this. Oops, something like this. And we'll go from A to B, A to B. And then we can say, so the average value somewhere between A and B, excuse me, is going to be somewhere, so if these are all my little y values, my average value would be somewhere, on this board I cannot do a dotted line and it drives me crazy. Okay, I have to do, I guess, a really slow dotted line. Okay, something like that, but probably a whole lot better. So there's this value, f of c, that would be my average value. Okay? And you can see area-wise, if this was better, that there's some area underneath it and some area above it. And the idea is that those areas would kind of even out, right, if that's the average. Does that make sense to you? So what we've done is we've taken this weird shape that we don't know how to geometrically find an area of, that's why we integrate, and made it into this perfect rectangle that would actually be where the average value is at that y value. Okay, so if I want to find the area of this, the f of c is the height of this rectangle, right? That's my y value. And then the b minus a, that's the length of the base. So the area of that perfect rectangle would be f of c times b minus a. Do you see how that works? That f of c, that is the average y value from A to B. Okay, so then we have this. So if I integrate, this is my f function, right? If I integrate f from A to B, that gives me this area right here. That's what this is, right? That's equal to the area of this perfect rectangle over here. F of c times b minus a. That make sense to you? All right, so if I want then what the average value is, if I'm looking for this, then I can divide both sides by b minus a, right, to get that by itself, so that I get that the f of c is equal to 1 over b minus a times this integral. That gives you the average value. Where this would give me the total accumulation, right? This would give me what the average value over that interval is. Okay? So how much total, because remember this totals it up, so it's just like you take the average of anything. You add it all up and divide by how many there are. You're adding it all up, that's what your integral is, and you're dividing by the difference in your x values. That's the way you find an average of anything, okay? Mm-hmm. You do not get a formula sheet. But it's one of those things, where once we do it for a while, you know that this is the accumulation, and anytime it asks for average, you just multiply it by that. Like you'll get to it where you won't feel like you'll need it. I'm like, do you need one that gives you the area of the triangle anymore? No, because you've been finding the area of a triangle. I know it's been years, and this isn't years, but you'll get there and it won't be that bad, okay? I promise you I'm not. All right, so then I guess my shirt is drawing for me. I don't know what the heck is going on right here. All right, so that's what this is, f of AVE, although I usually use AVG for average. So I want the average value. So it says here, I want to find the average value. So average value on this interval from -2 to 5 of the function of f. So let's find, that means I want to find f, the average, okay? That's going to be equal to 1 over, so my interval is from 5 to -2, I'm sorry, from -2 to 5. So I do 5 minus a -2, the integral from -2 to 5 of f of x dx. Okay, that's how we find the average value. Make sense? All right, because we add it all up, and then we divide by the difference in the x's. That's what's happening there. Okay, so let's go back over here, and let's find our areas. So you want to use this as one big, would you use this as one big triangle or 2 little triangles? It's preference. It really doesn't matter either way. One big one just gives me one number, but you could use 2 little ones. Sometimes when it's split like that, I know naturally you want to do that. But somebody, okay, that was two, somebody be the tiebreaker. Are we using one big one or 2 little ones?
One big one.
Okay. All right, so that means the base is how long? 3. And the height is 3. 3 times 3 divided by 2 is 9 halves. I know it's a tough one. All right, what's the radius of this circle? The radius is 2. The area is 4 pi, but we have half the circle, so it's 2 pi. I know. When you're thinking one thing and I ask the question differently, like, it's all good. Okay. Are these all positive? Yes, because it's all above the x-axis, and we're going from -2 to 5. We're going from left to right. So remember, we got to pay attention to that. I'm going left to right, and it's all above, so everything's positive. So that means here, this is going to give me 1 over 5 minus a -2 is 7. When I integrate this, okay, that's just adding these areas, right? So this is going to give me 9 halves plus 2 pi. Can I stop there? Yes, I'm going to stop there. If you had done these separately, you would have gotten 3 halves and 3. So if you have this as 3 halves plus 3 plus 2 pi in there, totally fine. Stop. Stop. Okay? We good? What questions you got? All right. So this says to find the average value of f on the given interval. All right, so our average value, so f, the average value, is equal to 1 over the difference in the interval, so 2 minus a -1 times the integral from -1 to 2 of 1 plus x squared dx. That's something you can handle okay? You don't have to, because it's like a polynomial, so you can, I mean, you can separate them if you want to, but you don't have to physically separate them. You can just kind of do a piece at a time, okay? So here, that'll give me 1 over 3, right? Then I'm going to integrate this. When I do that, what does the 1 become? X. Plus, what does the x squared become? X cubed over 3. And I don't need my c because I'm evaluating, right? So then I'm going to say I'm going to evaluate that from -1 to 2. Okay? Everybody with me? Well, I'm not finished. You can't, this is not a safe stop. You have to at least substitute it in. Okay? So then we get 1/3 times, all right? So what do I do first, the 2 or the -1? The 2. So I get 2 plus 2 cubed over 3, right? You're allowed to put 8 over 3, absolutely. Minus, I have 2 terms, so I am putting it in parentheses. -1 in here gives me -1 plus -1 cubed over 3, and that is my answer. Can leave it like that. Okay? We're good? Now, if this was not a free response question, if it was multiple choice or we needed the value, then we would need to continue. So let's just go ahead and continue. This will give me 1/3 times, so that'll be 2 plus 8/3, right? Then plus 1, and then this is a -1, and then that would make it positive, so that'll be plus 1/3, right? So 1/3 plus 8/3 is 9/3, okay? So that's 3 plus 3 is 6. 6 over 3, which is 2. Why is that not what I got over here? What did I do something wrong? Oh, it's that's where this 3 came from. Like this was 6, and then I did it times 1/3. Do y'all agree with all my work there? Why do I feel like I did? This is not what I had. I probably did something stupid is what I'm thinking. So did 6, that mean 14/3? I did it right? Okay. I got 14/3. No, well, this is what I did here. So if this is 8/3, that would make this 6/3, right? And so that's 14/3. Yes. You'll agree with that? This is 8/3, yes? This is 2, which becomes 6/3. Wait, when I want to add those together, you get 14/3, right? Then I do minus, if this is 1/3 and this is 1, isn't that 4/3? Oh. Okay, so if I could, but what I did here, okay, wouldn't this be -4/3? Or no? Right? So then when I wouldn't take this and add 4/3 to it, doesn't that give me 16/3? Gives me 18/3 because I can't add. That's where I'm stupid. Okay. I was like, it was really bothering me. Like, what did I do wrong? Like, I felt like I did that right. Yeah, it's 18, not 16. Thank you. That's right. I did it a weird way, but it made more sense to do it that way when I actually wrote it out. Sometimes I do things really the hard way for no reason. Okay, so this says, how would you find the times on interval C from -1 to 2 where f of x is equal to the average? How could you find when it's equal to the average? Derivative, could you? B minus A. Yes, but what are we're looking for, find the time. Okay, the times, find where is what it should say, because it's not really a time. Like, that's a bad use of that word. We're not really talking time. But find where is what it should say. Find where C is, find when, I guess, C on the interval from -2 where f of x is the average. So if you have, what is the average? 2. So if 2, I want to know when 2 is equal to this, right? Yeah. 1 plus x. I don't plug it in for x. I do that. Yeah, plug it into the y. Okay. It's plus and minus 1. Okay, let's solve it. This gives me 1 equals x squared, right? So x has to be equal to plus or minus 1. So those are the times, and that time is it's not literally like in seconds. That's a bad use of words there. That's not on the AP test. That was just a little bonus brain exercise. All right, so let's look at what happens with the charts here. So it says, oh, that is not an eraser. Oh my gosh. Yikes. All right. The table below gives the values of a continuous function. Use left Riemann sum with 3 subintervals and values from the table to estimate the average value of f on this interval. So average value of f, and they give us f, okay? So that's important to note there. So we can find the average value. F average is equal to, do 1 over the difference in the x's, so 17 minus 5. Okay. And then I'm going to integrate, so that's times the integral from 5 to 17 of f of x dx. Okay. Y'all agree with that? And then this part right here comes from the left Riemann sums. Okay, so my left Riemann sums 3 subintervals. So here's my 1, 2, 3 subintervals. The difference here is 4. The difference here is 3. The difference here is 5. Okay, we good with that? So when I go to substitute this in, this is equal to 1 over, so 17 minus 5 is 12. Right? Please make sure I can do my math. And then I'm going to do my area of my triangle, or my rectangles. This is going to have 4 times, this is the left Riemann sum, so which one of these two do I use? 23, the one on the left. Plus 3 times what? 29. Plus 5 times 36. And then we stop. Oh, but here's the difference here, and I missed this. So here, I'm actually integrating the actual thing. So this is the average. It is equal. This one, we're estimating. So this should be my little equals here. The squigglies. Because we are estimating. So the average is about that. That's what it means. Mm-hmm. Anything when it's not exact. It depends on the question. It could be that it doesn't matter at all for the specific question, depending on what they're looking at. It could be that that is a point. I doubt it would be more than 1, but so not completely the end of the world, because really they're looking at more, do you understand the calculus? But understanding the calculus is understanding the difference between estimating and getting the actual value as well. Okay. Misuse of equality. I know she uses those phrases and I have to go write them because I forget what, I know it's bad, but like I can't come up with the phrase that she has. Misuse of equality. We don't do. No. Yeah, you're lucky. You're very lucky. I know, me too. She is great. Yes. Okay. So the temperature of the water in a tub at time t modeled by a strictly increasing twice differentiable function w, where w of t is measured in degrees Fahrenheit and t is measured in minutes. Values of w of t at selected times t for the first 20 minutes are given in the table above. That is a lot of information, but they do not give you random stuff that doesn't matter. If they said it, it's probably important. So although when you first read it, you may not really think about how all that stuff's going to come into play, but as you're working through the questions, you need to make sure that you go back and think about what's being said here. All right, so it says use the data in the table to estimate, here's that word estimate again, estimate w prime of 12. Show the computations that lead to your answer using correct units. Interpret the meaning of your answer in the context of the problem. Okay, so we want to estimate w prime of 12 from this table. Are we going to be integrating? Okay. I'm looking for what is the derivative usually, what does the derivative represent? Slope or the rate of change, right? At a point, exactly. Instantaneous rate of change. So I want to know I'm going to estimate what is the rate of change at 12, right? They did not give me a w prime. They gave me w. So isn't the rate of change just the slope? So w prime of 12, we're estimating, is about, right? So 12 goes right here. This is where you just, you're doing the slope. So this is equal to W of 15 minus W of 9 over 15 minus 9. Okay, so you're finding the average rate of change, basically, but it's not the average value. That's something different. So then they gave us the 15, right? So this is 67.9 minus 61.8 over 6. And of course, you can leave it like that. But it does say using the correct units. Now, this one, I went back and looked at where it originally came from. It is a calculator question. We don't need the calculator for the pieces that we're doing, but it is a calculator question, so you could actually come up with the actual value. Either way, this is fine that we don't have the actual value, but I still need my units on it. The numerator is representing degrees Fahrenheit. The denominator is representing minutes, right? All right, so I got my units on there even though I didn't finish it up, and that's fine. But it does say using correct units, so I've got that right there. Interpret the meaning of your answer in the context of the problem, okay? So what does this even represent? Okay.
The rate of which the degrees of Fahrenheit is increasing by 6 point, or that.
Yeah. Yeah, it's 6 points. Okay, awesome. So how do we know it's increasing?
Why? Because from 9 to 15 goes to 51.
Okay. It's positive. It's also always increasing right here. Strictly increasing. Think about what if this was like a crazy number, like it had, I don't know, e's and natural logs and square roots in there, and you weren't sure if the value was actually positive and you don't have to go any farther. The fact that it's strictly increasing, we know it's still increasing, right? You are right, though, it is positive, and so that all works that way, too. Yeah, but it would be a calculator question, so you can figure it out. So, but you wouldn't necessarily have to because of what it says. Okay, so we can say you can say it however you like in different words because we all say it a little bit differently. But so we could say the temperature of the water. Is increasing. Can I say at a rate of or at an approximate rate of and then that at t equals 12 minutes. So I used my minutes in here. I have, this is my value with my units on there. Oh my gosh, I'm writing all over this part. Oh no, wrong one. Undo. All right, we good? All right, somewhat, okay. So then it says, for T being between 0 and 20, so that's what our table is, the average temperature of the water in the tub is this. So average temperature, and they give us this little setup, like we didn't even have to, oh my gosh, I'm still erasing. Average temperature, and they give us this, so we don't even have to come up with it. But it says use left Riemann sum with 4 intervals indicated by the data in the table to approximate that, and then does the approximation overestimate or underestimate? So let's first start with just finding it, okay? So the average temperature, so let's see, water average is equal to 1 over 20, let me just do this, times the integral of from 0 to 20 of W of t dt. So I don't know that you necessarily have to rewrite that, but I did. So that means this is equal to 1 over 20 times, all right, so this is where we're going to use our left Riemann sums with 4 intervals. All right, so here's my 1, 2, 3, 4. So this difference is 4, this difference is 5, this difference is 6, this difference is 5. Okay. So my first one's going to be 4 times what? 55, because it's a left Riemann sum. If it was a right Riemann sum, what would that number be instead?
57.1.
Very good. Plus 5 times, this time I do use 57.1, plus 6 times 61.8, plus 5 times 67.9. Oh my gosh, my handwriting gets worse and worse. Okay, so that's what we get, all right? Oh, yes, because we're estimating, approximating. Only squiggles here, but then after that, like if I was to continue that on, then they become equal signs because the rest of that is equal to each other. All right, so then it says, does this approximation overestimate or underestimate the average temperature of the water over these 20 minutes? It's a left Riemann sum. So what do we need to know about the function? It's increasing. Is it always in? It's continuous? It's strictly increasing. Now, let's pay real close attention to this because I've fallen into this trap before. It looks like when we look at this, that this is increasing, right? When we just look at the data. But nothing says that if this was just our plain old data and we didn't know anything else, that this couldn't be like, I don't know, 48 right here, and it couldn't like drop and that it's not increasing. So that we can't just go by that because this data is not continuous. The function is, the data is not, so that's not enough. The fact that it tells me this is what matters. Or if there was another way for me to figure it out, but be very careful not to fall in that trap because then we wouldn't know necessarily. They'd have to give us some other information. Okay. Or it would have to be one of those where you knew from the derivative that it was increasing, or what, you know, that type of thing. Okay, so what do you do if you're not real sure? Draw. It's increasing. We don't care what it really looks like, right? It's increasing. I do my left Riemann sums, and it looks like this, right? And so that's clearly an underestimate. Make sense? Like you don't have to draw it. That's just for you to wrap your mind around it if you need to. So then you need to say this approximation is an underestimate. Oh my gosh, let's spell it right. Underestimate. Because I guess I can just say W. W is strictly increasing and we used left Riemann sums. Okay, because you have to say, when you explain your reasoning, that's why. It's increasing and we use left Riemann sums. That's how we know that it is an underestimate. Okay. What questions do you have? Nothing? Okay. All right, find the average value of the function on the given interval without integrating, okay? So that means we're not actually like integrating those functions. We are using geometry, and so that means we're using the graph. So let's plot this. From -1 to 3, this is my function. So if I substitute in -1, 3 minus a -1 is what? 4. So at -1, I'm at 1, 2, 3, 4. I'm at 4. right about there. At 3, I'm where? 0. Okay. Then these are both linear. So 2x minus 6. Well, if I put in 3, I'm still starting right there. If I put in 6, I'm at what? No, 6. At 6, we're at 6. Okay. It's hard when it's not a grid. Okay. I think I made that look okay. So we have this, right? And we want to find the area. All right, so I'm going to use this as 2 different triangles here. So 1, 2, 3, that's 4 times 4 divided by 2, which is 8. And then I have 1, 2, 3 times 6 divided by 2 is 9. I know, it's the hard questions that get us every time, right? Okay, so we want the average value, okay, that's going to be equal to 1 over 6 minus a negative 1 times the integral from negative 1 to 6 of f of x dx. Okay. Everybody understand where everything's coming from? All right, so then this gives me 1 over 7 times, well, this right here is coming from the areas 8 plus 9, and you can leave it just like that. And I suggest you leave it just like that, so you don't do something stupid like I did, and I can't add 14 and 4 and can't figure out why I can't get the right answer. Okay, we good? Questions? All right, one more. Julian's heart rate during a workout is modeled by the differentiable function h, where h of t is measured in beats per minute and t is measured in minutes from the start of the workout. Using correct units, explain the meaning of this in context. I'll give you a minute. You think about it, talk about it, write it down. That's fine. Because that's BPM's an actual, like, notation. It's not like you're making something up, so it's fine. Okay, so I heard a lot of good discussion. Now, this is what I have. Your words would not have to be exactly the same, but there are some things that you have to make sure that you say. The fact that it is Julian's average heart rate, that you've used beats per minute, and from, whatever. Okay? So if you if you worded it backwards or whatever, it's totally fine. I heard some things about increasing and decreasing. This, even though it's its heart rate, it's not the rate in which his heart rate is increasing. Does that make sense to you? So that word rate, I think, kind of threw y'all off a little bit. But this does show me that it's because this number is the difference between these two, not just because I have a number out there, that I am doing, something. That is my average heart rate, or his average heart rate. Okay, does that make sense to you? We good on that? Okay. Any questions? All right, so you have a test tomorrow. You have a review.